Hello, everyone, and welcome to Climate Australia. My name is Lee Constable, and this is another episode in our series with the ARC Centre of Excellence for Climate Extremes. I'd like to start by acknowledging the traditional owners of the land on which I am broadcasting to you from today. I'm on the land of the Turrbal and Yugara people, so I'd like to pay my respects to elders past and present, and of course acknowledge the ongoing relationship that Aboriginal and Torres Strait Islander people across the First Nations that make up what we call Australia have with land, sea, and sky. Speaking of all of those things, today we are talking about marine heat waves. The title today is Boiling Point, the rise of marine heat waves and their impacts. And we have three researchers from the Centre of Excellence here to talk to us about what the marine heat waves are, what's happening and has happened, and what might happen in the future as well. So I will introduce them one by one. I'll first start by introducing you to Professor Neil Holbrook. Let me tell you a little bit about Neil. Neil is a professor of ocean and climate dynamics. His expertise is in the ocean's role in ocean and climate dynamics, climate variability, extremes, and climate change. He is best known for his research on South Pacific Ocean region climate change, variability, and extremes. Welcome to the show, Neil.
Thanks very much, Lee.
Great to have you here. And joining Neil, we've got one of his colleagues, Dr. Jules Keiter. Jules is a research fellow at the Institute for Marine and Antarctic Studies at the University of Tasmania. His research focuses on understanding the dynamics, evolution, and predictability of marine heat waves. So welcome to the show, Jules.
Thanks for having me, Lee.
My pleasure. And it's also my pleasure to introduce, last but not least, Yujing Wang. Yujin is a PhD student and she's at the Institute for Marine and Antarctic Studies at the University of Tasmania. Yujin's PhD is about understanding the predictability of marine heat waves using linear inverse models. So I really am excited to hear about that. And of course, it's great to have your expertise here as well, Yujin, as we are looking at not just what has happened, but what will happen and how we figure that out. So we'll start by setting the scene with you, Neil. Could you explain first what is a marine heat wave?
Well, that's a good question, Lee. Really, I guess we all think about what an atmospheric heat wave is. You know, we have a few days of much warmer weather or hotter weather in a row. A few days in a row like that, and we're familiar with that. And if it's like an extreme for a longer period of time, we're familiar with that as a heat wave. Well, in the ocean, they're very similar. You know, you get the same sort of thing. You get warmer, much hotter waters than you would normally feel, what would normally be at that particular location. And that puts stress on marine species, just like we feel in the atmosphere. We get stress on our bodies, heat stress. And really, that's really, I guess, what marine heat wave is about.
Yeah, and I think a lot of people have been learning only very recently that this is a phenomenon that occurs. We're more than familiar with heat waves on land that we experience and have to prepare for. Neil, how long have climate scientists been aware of marine heat waves?
Well, I guess we've been familiar with hot water or warmer water for multiple days in a row, but it was really only in 2011 when there was this big marine heat wave off Western Australia, which later got called the Nino marine heat wave. And that was identified as a very, very big, extensive blob of warm water off the Western Australian coast. It had devastating impacts on kelp species. There were species of fish that were seen that they hadn't seen before. Kelp died. There was seagrass in Shark Bay in the western tip of Western Australia that died. I think about 36 to 40% of the seagrass were affected. And the recovery of all of those things has been quite slow. Many things haven't actually recovered. And it really, I guess, from that point in time, the marine heatwave language really got coined. And there's been then a lot of excitement around trying to understand how marine heat waves, I guess, are formed, when they might disappear, and understanding potentially how they might change in the future.
Yeah, and I mean, what they do to the environment is very interesting. You mentioned new species emerging and things like that. There can be more devastation, obviously, on different species. I wanted to turn to you, Jules, just to ask about impacts and what you've found, particularly talking to, people in the fishing industry and other stakeholders.
Yeah, so marine heat waves can ecology and environment in a number of different ways. Sorry, I just realized my internet's breaking up a little bit. Hoping that's okay.
You can just start again, maybe, Jules. We only lost you for a second.
Sure. Yeah. So I was just saying that marine heat waves can impact the local ecology and marine environment in a number of different ways. So Neil's already alluded to these impacts on, say, kelp and seagrass in Western Australia. There was another major marine heat wave in the northeast Pacific Ocean off the Pacific coast of North America back in 2014-15. So that particular event was quite a long-lived marine heat wave, lasting around about 2 years, which is actually another point to stress about marine heat waves and their difference with atmospheric events. They can be really long-lived. So we tend to think of...
Sorry, Jules, was that the one they called the blob?
Exactly, yeah. So that was the event affectionately dubbed the blob. Received a lot of attention. That particular event caused, massive die-off of fish, seabirds as a result, sea lions. So really quite a dramatic change in the environment. We've also been looking, for example, around Tasmania on the impacts of marine heat waves to things like oysters and abalone and salmon. So in oysters, for example, we know that extremely warm temperatures can trigger a disease known as Pacific Oyster Mortality Syndrome, or POMS. They can...
Oh, we just lost you there after explaining POMS to us. So maybe if you just go to after you said that bit.
Yeah, so POMS is a temperature-triggered virus in oysters. We've also looked at impacts on abalone. They can cause weakness in abalone and reproductive failure, sometimes mortality. They've also impacted the salmon industry. So marine heat waves, for example, warmer temperatures can reduce the rate of feed conversion into growth in salmon. So there are a whole range of impacts, coral bleaching and so on.
And Neil, from your perspective, how do you kind of measure these things, or without going into obviously what Yushin's going to talk about soon, how do you measure these things and what are some of the big challenges?
Well, one of the ways that we get a more global perspective of temperature change and potential marine heat waves is really from satellite remote sensing of sea surface temperatures. So there's a pretty wonderful observing system of satellite now, and with, I guess, sea surface temperature records back to the early 1980s. So we've got, close to 40 years of satellite sensed sea surface temperatures. And so that's really good then to try and understand temperature change at the sea surface. But if you want to look at marine heat waves below the surface, you need something else. And so things like autonomous floats and moorings, there's things like Argo floats, they call them, that float around. That makes it a little bit more complicated because they move around in currents, and to try to understand how temperatures change at a particular location needs a bit of thought. But the other thing you can do, it's not really measuring, is just understanding the ocean and how changes are from models.
Yeah, and Yushin, I wanted to bring you in at this point because your research is really important when it comes to what Neil just mentioned, understanding from models. And Neil also mentioned Ningaloo Nino?
Nino, yeah.
Yeah. Could you explain to everyone what Ningaloo Nino is?
Ningaloo Nino is actually a called the marine heat waves happens over the Western Australia coast, and it is kind of a recurrent marine heat waves there, and in recent decades, and caused like the extended coral bleaching and the kelp forest kill. Yes, and
yeah, I think kelp forests are really important, aren't they, for the broader ecosystem?
Yeah, that's it. That is correct. And I am actually looking at the predictability of marine heat waves there. But the predictability of marine heat wave and the prediction is actually in its early stage, and it's inadequate and almost nothing there. So, but people has realized, and it is checked, and more and more attentions and considerations recently, because as Neil and Jules said, marine heat waves can have many negative impacts, and people start to realize if we want to reduce those devastating consequences, so the understanding the predictability and try to like develop a skillful prediction system is very important.
Yeah, so that's what your research is really trying to do, isn't it? It's like you said, there's not been much before, but now you can hopefully start to draw some lines between events and other factors. How are you tackling this question about predictability?
I am actually I was building in my own dynamical model based on the observed ocean temperature record to try to find whether some like climate variabilities or ocean circulations could be the common and reliable precursors for the historical Nino events, and then provide predictability. So the climate variabilities can have like longer time scale persistent and propagation. So I'm really focusing on the longer time predictability of Nino, like few months to up to like 2 years predictability. And based on my current findings, I found the climate variabilities in the Pacific Ocean, like the ENSO, could potentially provide several months predictability for Nino, and the climate variabilities in like Indian Ocean could even provide longer predictability.
Wow. So, I mean, for those not from Australia who might be watching, Ningaloo is over in Western Australia, and we think of ENSO, the Pacific, on the eastern side of Australia. Did you expect? I mean, it's surprising to me as a non-climate scientist, but did you expect those things to have such a link?
Yeah, definitely, because it's have like some because like ENSO events could have bring some the warm water from the equatorial region to the Western Australia coast. Is like through the ocean circulations and bring the warm water to the Western Australian coast, and the marine heat wave happened.
Mm-hmm. And does that go under Australia up the west coast, or the other way, the warmer water to the western side?
It's just some La Nina like ENSO events can enhance the transport of the warm water to the WA coast, and that's it.
Wow. So interesting. So it's obviously there's no shortage of work for you to do on these huge questions, which I'm sure will span far beyond a PhD project. So Jules and Neil, I was wondering if you could comment on some of the other examples of Australian marine heat waves we've had, for instance, in the Great Barrier Reef.
I'm happy to talk to this one, Neil.
Yeah.
So the Great Barrier Reef is kind of obviously as we know, a kind of sensitive and delicate, pristine environment. It's experienced a number of marine heat waves in recent years. Since 2015, the Bureau of Meteorology reports that there have actually been 3 mass coral bleaching events in those few short years. One thing that I find kind of scary, and so Neil alluded to this, and Yushin have talked about this 2011 Western Australian marine heat wave, which had a really huge impact on that environment there, and really was a kind of step change in the environment. So that marine heat wave that occurred there was classed as a Category 4 marine heat wave. So we have this categorization system for marine heat waves. That one was a Category 4. The Great Barrier Reef, even though the Coral Sea, has experienced these marine heat waves, it's yet to experience anything on a widespread scale that's approaching Category 3. So it hasn't had Category 4, barely experienced Category 3. I mean, it's just it's scary to think that the devastation that a Category 4 marine heat wave would have on that environment.
Yeah.
So other areas that I've been focusing my attention on is around Tasmania as well. So there have been 2 major marine heat waves there in recent years, in the summers of 2015-16 and 17-18. The 2015-16 event was quite a long event, so 300 days in duration. The 2017-18 was slightly more intense, but shorter duration. So yeah, there's a number of examples of these events, and more and more work is being done to link those two impacts.
So when we think of heat waves on land, they might last for days, but when we're talking heat waves in the ocean, they're lasting for, almost a year in that example you just gave. Wow. And I know that kelp forests have really been impacted greatly. I was wondering if you'd like to let people know about the heat waves that you've seen in the areas around Tasmania and the effect that that's had.
Yeah, so this is not actually my area of expertise in terms of the kelp, though I am quite aware that a lot of kelp has been wiped out from around Tasmania. However, I saw this story just earlier this week, actually, where they've started to grow kelp in the lab and reseed it back into the environment, and had huge success with it growing again, and it can grow quite rapidly. So it seems like there's some possibilities for reseeding with the research going on.
Yeah, great. Now, Neil, I wanted to ask you about what's next. Obviously, we've had the IPCC report of the physical science of climate change, and marine heat waves was one thing mentioned in that. We're leading up to COP, so a lot of people are thinking about the future and targets and things like that. What do we know about the potential ways that marine heat waves might respond to different levels of warming in the future?
Well, there's quite a close association between long-term increases in sea surface temperature or ocean temperatures in general, so whether it's through the whole water column, and marine heat wave incidence. So we think about metrics of marine heat waves in terms of frequency, intensity, and duration. And all of those factors are basically increasing with climate change. So as sea surface temperatures warm, the frequency, intensity, and duration of marine heat waves is basically increasing. We've seen over the last 100 years or so an increase in the number of marine heat wave days at any location on average of about 1.5 times. So about half as much again. And basically this is projected to continue into the future. And we're really, in effect, tied to our projection pathways depending on how much greenhouse gases, I guess, we put into the atmosphere. So going forward, it's going to be really important to mitigate and reduce those emissions in order to try to reduce the impact on marine heat wave likelihood and intensity going forward into the future.
Yeah, I think it's something obviously people are going to be looking to work like Yijin, what you're doing to try and help predict. What sort of benefit could it have if we're able to better predict heat waves in the future?
So I guess the biggest benefit is the marine heat wave predictability, or potentially prediction system could allow people to take actions in advance before marine heat waves when they see like a precursor of marine heat wave signal, to avoid the losses and caused by marine heat waves. For example, like for agriculture, if we can get like short-term marine heat wave prediction in few days to few weeks, and could allow people to take short-term action to those farm species in agriculture industries, and that would like the species that would like suffer mortalities under marine heat waves, and you can like relocate them or something like that. And if we can get longer timescale forecast, like months to years, it can provide some guidance for the agriculture and fishery management decision. Like if we can predict there will be a more frequent marine heat waves events in the next year, then we probably can suggest the fishery industries to change their like targeted species to those species that have high tolerance to the warm water.
Yeah, wow, that I can see why that would have huge impacts on people's lives and livelihoods, as well as the ecosystems themselves. Jules, what have you found from talking to people in the industry? Are they really concerned about their futures with marine heat waves?
Yeah, and I mean, there's a lot already going on, I think, in the industry for preparing for these. The oyster industry is, well aware of the changes that they're seeing, for example, in Tasmania. They're already doing things like selective breeding for this virus that I talked about, POMS. And yeah, just as Yu-Xin says, if we had kind of seasonal forecasting capacity for these marine heat waves, I think it would be hugely beneficial to the planning for these industries, just even on a seasonal scale. So again, coming back to the oyster example, that on the very short term, that they can do things like bringing the oysters out of the water or pushing them to deeper depths to avoid some of those impacts. Yeah, there's a range of other things. For example, the salmon industry can alter their harvest practices if they know that the season might be warmer than usual. So just like farmers, I think, can prepare for the upcoming season if they know that there's going to be more or less rainfall. This understanding of what the next season or few years might be would be beneficial.
Yeah, absolutely. And obviously it has huge implications for food security. I also wanted to ask, what is the applicability of what we learn about the Australian marine heat waves to the rest of the world? Is it going to be something where it's like, that makes sense for that part of the world, but we need totally different models? Or are there shared understandings between the different areas?
Did you want me to have a go at that?
Yeah, go for it, Neil.
So there, I mean, I think one of the things that we haven't really talked about are the key drivers, I guess, of marine heat waves. And in the context of what Yu-Xin was particularly talking about, these shorter time scale predictions rather than long-term projections. So the key things that really cause marine heat waves that we tend to think about are basically just enhanced solar heating, like, basically like clear sky days, a big high pressure cell, and extra heating of the surface ocean. So that would heat the upper ocean more than it would normally feel, let's say. And the other thing is through ocean currents. So in these what we call boundary current regions, let's say off the East Australian coast or off the Western Australian coast, there's influences there basically from just an atmospheric heat wave or a very, very hot days over a few days heating the ocean surface, but also an intensification of either of those currents, let's say. And these have similar applications in different parts of the world, I guess away from the center of ocean basins. The benefit of understanding those is how it's tied back to large scale climate. We call them climate modes. So they're understanding patterns of variability across the globe. And those climate modes, things like El Nino Southern Oscillation, if people have heard of that as an example, they have some predictability as well. So then we start to think about predictability on well, we think about a high pressure system that might be just a few days in advance, so there might be short time scale predictability there. But these large scale climate modes can have predictability on longer time scales and influence through ocean circulation on much longer time scales. So the ocean then becomes an important factor then in predictability on time scales of months to multiple months to even a year. Whereas, let's say the weather, which is much more random, let's say, and shorter time scale, might have predictability on days to a week or so. And it's just combining all that information that gives you, that we can potentially build these predictive models that we're aiming to do.
Yeah, well, it's great to know that we've got researchers working on this in our local area, especially given how girt by sea we are. But it's also important, I suppose, for the whole global community of climate scientists, given that everything's related, in this climate, nothing is separate from the other impacts and factors. So basically, I'll give you all one more question, and then what we're going to do is go to some credits and come back and take a few questions. Just some rain coming down here as I say that. So I might go around one by one, and maybe if you can tell people one thing that you'd like them to take away from this or learn more about if they're interested in marine heat waves, whether they're policy people or business people or everyday people who love a bit of seafood. Neil, I might start with you.
Well, I think if you're a policy person or any stakeholder in industry, government or whatever that's needs to understand marine heat waves and the impact on society, we do really need to improve our understanding of predictability and prediction systems. And one of the ways that we really need to do that is to better understand the drivers and the timescales of those drivers that give us that potential predictability. That would be my take home.
Yeah, plenty of good justification for all of the questions that you're all trying to answer at CLEX. Jules, would you like to go next?
So one of the pieces of work that I've been involved with is looking at projections of marine heat waves going out to the end of the century over the next several decades and beyond. And one of the things that we've kind of found is that, we kind of have a choice here. If we follow something like a kind of a low-end emissions scenarios trajectory, these marine heat waves that we're experiencing today will be kind of the same order of frequency of occurrence in future going out over the next few decades. But under a high emission scenario, the future's starkly different. These marine heat wave conditions will become a new normal. And I think we have a choice there. The science shows the two options. And I think for me, at least, the choice is pretty clear.
Yeah, we then I suppose, like you said, it will be the new normal. We'll end up having cool waves rather than heat waves, I suppose, under that scenario. Very good. Yushin, last but not least.
Thank you. I guess the take-home message from me is probably the marine heatwave predictability and the skillful prediction system are still at their initial stage. Although the marine heatwave prediction is not a very easy picture, but we can start with understanding the predictability of marine heatwave at first, like find the reliable precursors from various sources and keep adding the value to the marine heatwave prediction system. And that is worthwhile, and this really benefits the real world, especially the marine conservations, marine ecosystem, fisheries, and agriculture.
Yeah, and it's great to know that there are people like you who are looking into these things right now. Thank you all so much for joining me on this episode to do, pun totally intended because I'm headed right for it, but a deep dive into marine heat waves. Really appreciate it. I encourage anyone who's been watching to check out the CLEX website that's been coming up on screen, and check out the research done by the Centre of Excellence and, of course, our 3 guest researchers here today on marine heat waves. Thank you all so much.
Pleasure. Thanks very much.
We'll go to some credit. We're back and we've got some questions for you all to answer. There's a few here. What makes marine heat waves and their intensity and length so difficult to predict? Eugene, you've probably touched on this a little bit. Would you like to expand?
Yes, sure. So I guess the biggest challenge for like the predictability is I think it's actually the biggest challenge is to construct a skillful marine heat wave prediction system. So it is not easy to combine like different predictabilities from different physical drivers of marine heat wave to really build a strong prediction system. Even the marine heat wave in the same location but happen at different times may be driven by different mechanism, and different mechanism has different weight of influence to the occurrences of marine heat waves. So it is hard to quantify. And another thing is, although many previous studies have tried to understand the physical mechanism and physical drivers of marine heat waves, are they kind of the comprehensive understanding, or there are still some mechanism of marine heat waves that haven't been examined? So this could also influence the quality of marine heat wave prediction system and influence predicting the intensity and duration or frequency of marine heat waves.
Yeah, it's so interesting that you say like different times of years. So a marine heat wave that is initiated, I guess, in winter versus summer might happen for very different reasons. Is that?
Yeah, because so the mechanism of marine heat waves are varying for different marine heat waves and for at different locations. So some of them, as Neil Andrew said, maybe come from the solar radiation, maybe come from the atmospheric driver, and some of the marine heat waves may initiate by the ocean circulations and climate variabilities.
So, yeah, that's so interesting, and it's so complex. I mean, I'm preaching to the choir here. You're like, tell me about it, right? If only if it was simple. So marine heat wave precursors, this is another question I've got here, seem to be very similar to drought precursors. Do marine heat waves behave more like drought than heat waves, and with a similar environmental impacts except underwater? And I suppose that goes to that whole longevity of a marine heat wave and a drought. Neil, did you have an answer for that one?
Probably not a very good answer, but the types of precursors that you think about in the ocean is like how deep the mixed layer is. So in the upper ocean, we have what's called a mixed layer, where it's well mixed down to a certain level, usually from wave action, cooling, it could be at the surface, and so on. And if that mixed layer is deep or shallow, can be a precursor then to how it might respond to a warming event from the surface, let's say. So if it's a shallow mixed layer, for example, it's going to be more easily heated. So that might be a precursor to a marine heat wave event. And the type of things that I guess Yushin was just talking about too, those time scales, the short weather type things. When we think about weather forecasts, we think about, weather forecasts out to maybe 7 days, and then it goes off into, more chaotic. It's very difficult. But there's kind of two timescales that we think of. One is kind of the weather timescale, and the other is more like the climate timescale. And there's predictability on all of these timescales that kind of play into this, that make things complicated. So you might have a weather event that could actually enhance or reduce that likelihood of an event happening. And I think this is where the predictability gets complicated, whether your precursors are in place or not.
And I was just wondering, given that the water obviously reacts totally different with temperature and retains temperature in a different way to air, does that mean that does that make it harder to end a marine heat wave? Is it one of those things where, once you've got it in motion, it just a positive feedback loop continues?
Yeah, so the atmosphere is very fast by comparison with the ocean. The ocean, I always feel like it's quite sluggish. But it has this, because it has this kind of thermal inertia as well, it's difficult to heat it up, and it's very slow to release that heat as well. So the temperature changes that you feel in the ocean tend to be much less. So you have to actually provide a huge amount of heat to increase the temperature by just a part of a degree. So you're right. Yeah, it's much slower. It's harder to heat it up. It's harder to lose that heat, and the timescales then are much longer.
Yeah, I've got a question here. Andrew Watkins has been watching on Simpatico. First, he says, I missed the first half hour due to a meeting conflict. Don't worry, Andrew, you'll be able to watch it back afterwards, anything you missed. But he goes on with a couple of questions here. Firstly, would it be possible for us to have a marine heatwave early warning service for Australia? Now, I know that we've mentioned a bit about this. Yushin, maybe you'd like to have, how far do you think we are, Yushin, with an early warning service for Australia on marine heat waves?
As I said, marine heatwave prediction is not an easy work, and I don't know, probably Neil could add some additional information.
Yeah.
So what I can comment on is there is actually a marine heatwave prediction system being developed currently at the Bureau of Meteorology in conjunction with CSIRO. It's very early stages, and I think they've got probably about a 3-year plan around that. So they're building on the ACCESS model, they called it. It's the subseasonal to seasonal prediction model. But they're actually going to really focus on marine heatwave predictability or prediction in that model. So I think it's on the horizon. And I think they're very hopeful that they're going to be able to do this. But this would be one of the first systems probably that's run across the globe, really ambitiously trying to predict marine heat waves.
Yeah, and obviously the results of your research will be feeding into that and helping to make it more accurate with time.
Yeah, absolutely. I mean, one of the things really that the Centre of Excellence for Climate Extremes is really trying to do is better understand that predictability. So if we can improve the predictability and how that predictability will potentially improve prediction systems, we're actually trying to work collaboratively with the Bureau of Meteorology and CSIRO to improve those systems.
Andrew's second part of the question is probably already answers. I noticed that he's already said Yahoo while you were talking. Very excited, obviously, which is great. He said, and can you talk about the skill of predicting marine heat waves, particularly in areas with coral or kelp? I suppose that this would all be relevant for those areas of coral and kelp, wouldn't it? And definitely used by the people you work with, Jules.
Yeah, coming back to the question, it's probably, as Neil says, it's probably early days for these prediction systems, and I know that they do kind of they're constantly assessing the kind of skill of these models and how they might be improved. Yeah, I don't think I can comment too much on how well they've got the prediction system at the moment, but I know that that's always part of what they're looking at.
Yeah, and also noting, as at the start of this discussion, we talked about how marine heat waves themselves have only been something really looked deeply into for a decade. So it makes sense that the predictability and other things that we might be further along with in terms of other weather and climate events might be taking some time. Hence why you're researching these things, correct?
Yeah, I think the predictability in different regions is going to vary quite substantially based on the kind of drivers that really affect those areas. The thing with coral reefs is currently the definition that we use for a marine heat wave is a little bit different than what's actually used for coral bleaching. So they tend to think about sea surface temperatures like 1 degree above the maximum summertime value. And so their coral reef bleaching forecasts are done under a kind of a different system, I guess. But I think that's actually being also thought about a bit further as well. But I think just I guess reiterating that we're really trying to understand, I guess, drivers on different time scales. There's going to be potential predictability from all different factors, whether it be from, atmospheric means, from high pressure cells that are going to be very short time scale to those that are much more oceanic in nature. And if we can draw from the ocean side of it, we're likely to get longer time scale predictability.
Yeah. And I picking up on something you just mentioned there about different regions. So you also mean different regions of the Australian coastline will have be able to predict a bit easier than others. Could you expand on that?
Yeah, sure. So, for example, the Tasman Sea, which is, southeast Australia, between Tasmania, Southeast Australia and New Zealand, compared with the Western Australian coast. Early on in the interview, you alluded to the fact that El Nino Southern Oscillation, for example, ENSO, it seems a bit odd that we might get predictability in the Indian Ocean region of Western Australia. Well, it's kind of fascinating that in the ocean world, it's actually a pathway for flows and propagating waves that go from the Pacific Ocean into the Indian Ocean. And the predictability from what we call ENSO, El Nino Southern Oscillation, of Western Australia is actually much higher than it is in the Tasman Sea. Tasman Sea, really, the pathway is more from the interior of the South Pacific. And connecting that information down from the tropics is actually a bit more complicated. And so the relationship with El Nino Southern Oscillation in the Tasman Sea is actually much weaker than it is off Western Australia, which probably comes as a surprise to a lot of people.
Yeah, it definitely seems counterintuitive if you're outside of the field and don't know as much about it. What about zooming out from Australia to the world? Are there areas in the world that are much more susceptible than others in a similar way or different?
Yeah, so there are, I hate to use the term hotspots where marine heat waves are probably, have characteristic shapes and the way that they kind of might reappear. So there's been looking at marine heat waves off the California coast. There's been this blob that you talked about in the Northeast Pacific, which is very extensive, probably the biggest type of marine heat wave that's long-lived that we see around the globe. There's been a couple of significant events in the Northwest Atlantic off the Canadian coast and Northeast US. There's been the Mediterranean marine heat wave, Mediterranean Sea, that coincided with the big heat waves, atmospheric heat waves in the early 2000s, 2003, when thousands of people died actually in Europe, you might remember. And those regions are, characteristic of broader scale marine heat waves rather than just little, changes in, say, dots or eddy fields locally. And so understanding those broad events, those really iconic marine heat waves, is going to be really important for us going forward.
Yeah, and I suppose that when you're talking about vulnerability, there's the likelihood of heat waves to occur, but also then there's the likely impact on ecosystems and food systems in different areas will be different, because some populations have a higher reliance on the ocean for food than others. And there's so many different factors I can see coming into this. Are there areas of the world where you think they don't have enough research happening into marine heat waves, or aren't getting enough support to do enough research?
Well, I think, the Pacific Island region, for example, vulnerable populations to sea level rise and changes in ocean temperature that might affect things like ciguatera poisoning in fish. So those regions are probably regions that really need to have more information around changes in marine heat waves. But any of the more vulnerable populations, I think it's critically important. In some ways, it's really important, obviously, for, let's say, Australia in terms of aquaculture, farming and fisheries. But around the world, anywhere where populations rely on the ocean, they probably need as much information around projections and predictability to help them that they can as well.
Yeah, and I mean, Andrew Watkins again. Hi, Andrew. It's so great to have you chatting along with us. Noting the 2011 marine heatwave off Western Australia being massive. There's another question here that links to that on why we didn't pay attention to marine heatwaves before 2011. Did they just not occur, or was the impact of Ningaloo Nino so large that it activated the research? Eugene, you might want to start us off with that one.
Yeah, sure. So the first thing I guess is so previously the marine heat wave is not that frequent and it's not that intense. So it didn't cause many like very devastating consequences for the ecosystem of fisheries. But since the very intense marine heat waves raised up in 2011, and this just raised people's attentions, and marine heat wave is also very important for like the ecosystem, and there are many stakeholders that they want to know more about the heat waves and their impacts. Yes, I guess this is my answer.
Yeah, I can definitely see why so many different stakeholders would be interested.
Mm.
Great. Well, I mean, I could talk to you all day, but I do have to let you go so you can actually get back to doing the research. But thank you all so much. Before we go, are there any last additions you wanted to add? I know I'm always conscious. Have I asked all the questions have I asked the questions that you want to be asked or think should be asked? Is always a concern of mine. So yeah, add on anything else, and then I'll let you go about your research.
Maybe just one point that I could add is that we've talked about temperature extremes, but just to kind of stress, we're well aware that temperature changes are not kind of sole influences in some of these examples, and in particular, so some of the areas that I've been looking at, for example, with salmon and abalone, we know that temperature is obviously a critical factor, but there are other factors that are important too, such as, for example, salmon dissolved oxygen in the water. For abalone, they tend to like these wavy, aerated conditions, and so one of the challenges is understanding how some of these changes over time will interact with one another. Does one change offset another? Do they couple to create greater impacts? So it's not just a kind of one variable problem that we're thinking about here. There's lots of other factors wrapped up in it.
Yeah, that's a great point. And I mean, we've been talking about the marine world and climate for so long in this hour, and I have, none of us have even mentioned acidification and all these other things that come along with it. So thank you so much for adding that point. It's an important one for anyone watching this back who's thinking about ocean life and ecosystems and what the impact might be or could be, and how we might be able to mitigate and adapt. So thanks so much. Well, I will call it the end because like I said, I'm a question asker, so I could go forever. But thank you so much again for joining me, and thanks to people watching, whether you're watching live or watching back. Thanks for watching, and we'll be back again next month, and not too long, with another episode from the ARC Centre of Excellence for Climate Extremes. Thanks so much.
Thanks, Lee.
Thanks, Lee.
Thanks, Lee.
Okay, bye, everyone.